Hello everyone. Today we are going to recall two really important facts from geometry that are going to be useful for us moving forward. Namely, the distance formula and the midpoint formula. So to begin with, let's work on the distance formula. So let's say that we have a point x1, y1 and another point x2, y2, and we want to know the distance between those 2 points in the plane. Well, we can construct a right triangle as follows by dropping a vertical and a horizontal line down to produce that nice right angle. Whenever we see a right triangle in geometry, we probably think Pythagoras. Okay, so if that distance d between the points, which is now the length of the hypotenuse of the right triangle, if that distance is d, if I know the legs have length a and b, well, the Pythagorean theorem tells us that a squared plus b squared is d squared. If we solve for d by taking a square root, we get that d equals the positive square root, right, because distances have to be certainly not negative. So it's the positive square root of a squared plus b squared. Now, since we last viewed this in geometry, we've become a little bit more sophisticated as mathematicians, right? We can talk a little bit differently about what A and B are using our notation. So B, that horizontal length, is simply the distance horizontally between the points. So that's the absolute value of x2 minus x1, because that's how we can use absolute value to measure distance. And similarly, the vertical length is the absolute value of y2 minus y1. So if we substitute this into our formula, we get that d is the positive square root of a squared, so that's y2 minus y1 absolute value squared, plus b squared, so that's x2 minus x1 in absolute value squared. But since we're squaring, any negatives that might be lurking behind that absolute value notation will be squared away. So we can actually just take the genuine difference between my x values, my x coordinates, and square, and then similarly square the difference between my y coordinates. So our distance formula, let's wrap it up in this nice box here. It's the positive square root of x2 minus x1 squared plus y2 minus y1 squared. So let's roll this out with an example. We're asked to find the distance between these 2 points. So it'll be helpful for us, I think, to draw a little sketch. So let's say we have the point -1, 4, and then our other point 3, -2. We want to know what that distance d is. Well, schematically, all we're going to do is create that right triangle that we're going to apply Pythagoras to. So there it is. So we know that d is going to be the positive square root. Now it's really the distance, the difference in the x coordinates, which here we can see -1 up to 3 gives us a change in x of 4, and -2 up to 4 gives us a vertical change of 6. So our distance formula tells us to take the square root of 4 squared plus 6 squared, which is simply the square root of 52. Now, of course, we should simplify this. So 52 is 4 times 13, so we can simplify that radical as 2 times the square root of 13. We're also asked to round this, give an approximation to 2 decimal places. If we type that into a calculator, we should get 7.21 to 2 decimal places. On to the midpoint formula. Let's say that we have 2 points again, so a point A with coordinates x1, y1, and a point B with coordinates x2, y2. Let's say we want to find the midpoint of the line segment between those points. So I don't know, let's call it D here in the middle. The plan is the same as before. Produce a nice right triangle. Because now we can leverage the usefulness of similar triangles. I can produce a smaller, similar right triangle by dropping this vertical down here, okay? And now, since these two right triangles share that angle in common, and they both have a second congruent angle, namely the right 90-degree angle, we know by the angle-angle postulate, think back to geometry, that these two right triangles are similar. So what triangles am I talking about? Let's emphasize. We have this small one and this larger one. So what we're saying is, let's name that final vertex C. So we know from geometry that triangle ABC is similar to triangle, oh, I need to name that final point, don't I? Let's call it E, to triangle ADE, with scale factor 1/2. Why is that the case? Well, let's think about it. AD, that D is supposed to be the midpoint, so that better be half the length of the longer hypotenuse. So I'll leave this as an exercise for you, but you can conclude from this that E is the midpoint also of the line segment AC, and F is the midpoint of the line segment BC. So we want to figure out what the x-coordinate of E is and the y-coordinate of F is, because that will tell us the coordinates of D. Well, let's think about E. E is halfway between this x-coordinate x1 and this x-coordinate x2. How do I find a quantity that's halfway between two other quantities? We take the average. Okay. Similarly, to find the y-coordinate of F, we'll take the average of the y-coordinates y1 and y2, because that will give us the y-coordinate that is in the middle between them. So this gives us, as our midpoint formula, the point D, which we might call xm, ym, m for midpoint. The coordinates we're looking for, we simply average the x-coordinates, x1 plus x2 over 2 for the x-coordinate, and for the y-coordinate, we average the y-coordinates, y1 plus y2 over 2. Let's see an example of this in action. We're asked to find the midpoint of the line segment whose endpoints are 1, -6 and -7, -4. Let's draw a little schematic diagram for ourselves. So we'll have -7, -4 as one of our endpoints. The other endpoint will be 1, -6. We want to know what the coordinates of that midpoint are, xm, ym. Well, we just apply the formula. The midpoint is xm, ym. So I'm supposed to take the average of the x-coordinates, so that's -7 plus 1 over 2. The average of the y-coordinates, that's -4 plus -6 over 2, which gives us -3, -5 as our midpoint.